subtracting mixed numbers, part 2. Problem number 1. In this one, we're going to have two mixed numbers that are going to be negative. And as you know, negative and negative, we add and keep the sign. But before this, I need to see, do we have anything to reduce? Yes. Into 4, 1, into 4, 3. So, this is what we're going to do. We're going to get a common denominator for 15 and 3. For 15 and 3, the common denominator is, into 3 is 1, 5. Into 5, it's 1, 1. If we multiply, we get a 15. So my common denominator is 15. This will keep the 8. And this will have a common denominator 15. What did I multiply 3 to get a 15? 5 times 1, 5. So we add the 8 and the 2, and we have a minus 10, 13 over 15. And we can't be able to reduce. Problem number 2. Minus 12, 14 over 24, plus 15, 15 over 35. Can I be able to reduce or simplify any of the fractions? Yes, into 2, 7, into 2, 12, into 5, 3, and into 5, 7. If I get the common denominator for 7 and 12, it will be 84. So we put our common denominator as 84. And we say, what did I multiply to 12 to get 84? 7. So 12 times 7, 84, and 7 times 7, 49. 84 into 7, 12, times 3, 36. Now, when we have a negative and a positive number, mixed number, as with whole numbers, we can't subtract a big number from a small. So what we have to do is put the biggest first with its own sign, and the smallest after. And when we do so, we have already noticed that we can't subtract the 49 from the 36. So what I need to do is borrow. $120 into 84. Remember that we say in part 1 that we add these two, we get 120, and we write the other fraction like it is. Now we're ready to subtract. 120 minus 49, and it's 71. My answer is 271 over 84. And this can't be able to be simplified. Problem number 3. In problem number 3, I have, once again, a negative and a positive mixed number, and plus 20, 18 over 21, 81. The first thing that we need to do is, like in the other problems, reduce and reduce. Into 9, 3. Into 9, 5. Also this one, it can be reducible into 9. 2 into 9, 9. So my problem looks like this. I'm going to rewrite it. And as you can see, we can't subtract a big number from a small one. So I need to put the biggest first and the smallest after. And now we can say that the common denominator for these two will be into 9 to 5, 45. So I put here the common denominator 45, and I say, what did I multiply the 9 by to get a 45? 5. So I'm going to multiply these times 5, and I get 10. In this other one, what did I multiply the 9 to get 45? 9. So I multiply these by 9. 3 times 9, 27. Okay, we can't subtract because this is a big number and this is a smaller one, so I can't subtract 27 from 10. And that is something you have to be looking on your problems every time you have integers. We say, let's borrow. We will, as a shortcut, consider those two numbers to be added. And now we can be able to subtract. So we say 55 minus 27, it's 28. So my answer is 4 whole number, 28 over 45. And as you can see, neither 28 or 45 are divisible by any number, so my answer is 4, 28 over 45.